Is my voice audible?
Yeah, your voice is audible.
Yeah, fine. So any of you guys can tell what is today's topic? Okay, fine. It's about different parts of 3D printer. So can any of you guys describe what you have been taught for the past 5 sessions? So can you give me a brief description about past 5 sessions? Anyone? Hello? Yeah, please turn on your mic and try to say the answer.
In the first lecture, we were taught introduction to 3D printing.
Yeah. And
In the
then?
second lecture, we were taught Fusion 360.
Yeah, okay.
And
Next?
in the third lecture, we were taught Blender software.
Yeah.
In the
And then in the fourth one?
fourth one, we were taught Ultimaker theorem.
Yeah. Next?
And in the fifth, we were taught different types of 3D printers.
Okay, so can you just say some different types of 3D printing?
Yeah, there are three types, mainly filament based, resin based, and powder based.
Yeah, correct. And then, so yeah, just explain it briefly. There's nothing too much to go into detail. Yeah, no worries. It's just an interactive session. Be free to describe anything. Okay, fine. Thank you for the description of the past 5 sessions. So today we'll be learning about different parts of a 3D printer. So this is what we have covered so far. Introduction to 3D printing has been covered in the session 1, and the rest of the part is this. So can anyone say what FDM stands for? Someone please say what FDM stands for. Okay, so FDM stands for Fused Deposition Modeling. So it was introduced first in 19th century by Mr. Scott Trump, founder of Stratasys. Do anyone know about Stratasys? Okay, so basically how a FDM 3D printer works is initially a CAD file which consists of the like the given 3D model outprint will be in the CAD file, which will be converted to STL file and it will be given as an input to the 3D printer. So which starts the printing process. So basically now we are going to talk about different parts of a 3D printer. So motherboard, it's the one of the major component of the 3D printer. So it's also known as it consists of the microcontroller of the 3D printer. So generally it coordinates all the movements in the 3D printer coordinated by the motherboard. So in case if the stepper motor or an extruder, these are the parts which we'll get to know later in this session. So if you want these parts to move in a certain way, this motherboard is the main thing which coordinates these movements. So it's basically like a network system between the movement of the parts and the STL file. See, the motherboard, it has both 8-bit and 32-bit. It's based on the complexity of the prototype which you're trying to build. If the prototype is like complex, having too many difficult structures to be printed, then it's better to use a 32-bit microcontroller for the motherboard. If it's like a basic normal prototype like a Benchy or something, then it's better to use a 8-bit motherboard because it doesn't have too many complications in its G code, so it can print easily. So this is how a motherboard looks. These are the components of the motherboard. This is the internal structure of a motherboard. Okay, so can someone say who founded the FDM 3D printer? Just now I explained it, right? Okay.
Scott.
Yeah, it's correct. He's founder of which company?
Scrotasis.
Yeah, correct. Good. So now we are going to talk about frames. See, frame is like a base of the 3D printer. Without frame, the stability of the 3D printer will be very less. So it helps in maintaining the stability of the 3D printer. So generally frames are made of acrylic or metal. See, if we don't have proper frame for a correct 3D printer, so when you're trying to build on a print bed, the 3D printer won't be stable and you won't get a good prototype which you're trying to build. So having a good frame for a 3D printer is like a must thing. So generally frames can be opened or closed. See, when you try to use an open frame, generally the filament will be melted at very high temperature. By the time it falls on a print bed, it it will be around 300 to 400 degrees Celsius. So when it tends to cool down, it absorbs the moisture from the atmosphere. So the density in the filament on the print bed which is trying to print, so the density of the material varies. So in order to keep the density constant and the filament to not absorb the moisture from the atmosphere, it's better to use a closed frames compared to open frame. So what closed frame does is it insulates the 3D printer from the outside atmosphere, so there won't be any interaction. So there won't be any heat transfer or absorption of moisture from atmosphere. So the quality of the 3D print will be more in closed frames compared to open frames. So they try to maintain a consistent temperature inside the 3D printer. This is how a frame looks. This whole part. And there are even semi-closed frames also, not only closed and open. Okay, now we are going to talk about filaments. Do anyone know what filament is? So can anyone try to guess what is a filament?
It is the material which is melted down and 3D models are printed.
Yeah, good. It's correct. What he said is correct. So filaments are the things which are melted and used to build a 3D printing model. So these are different types of filaments which we have here. This is PLA. Do anyone know what is full form of PLA?
Polylactic acid.
Yeah, correct. ABS? Do anyone know the full form of ABS? Fine. It's acrylonitrile butadiene styrene. You guys know styrene, right? Okay, so can anyone of you guess which are the majorly used filaments in a 3D printing model?
PLA.
Yeah, it's PLA. Not only PLA, even ABS is also used as well. But PLA is used more. Generally, these filaments are stored in spools. Initially, the filaments are heated to a certain extent of temperature so that they tend to liquefy and we can use them to print the 3D model. So each filament has its own advantages and disadvantages. PLA is used because it's easy to work and its advantages are it is stronger and stiffer. So compared to other filaments, PLA is stronger and stiffer. So it is better to build a 3D printing which is 3D printing model which is strong and stiff. But the problem with PLA is it has less heat resistance. So when you consider you are trying to build a prototype for like rocket propulsion or something. So when you try to use PLA, then the temperatures which you tend to reach in those projects is certainly high. So when you try to build a prototype model using this PLA, you can't build it because of the high temperature, this model starts to melt. So it can't withstand the high heat resistance. So in those cases, we'll be using ABS, which is acrylonitrile butadiene styrene. This has got high heat resistance properties, which is used for functional prototypes. So basically, PLA is used for general purposes like printing a normal 3D object. PLA is used. So for building functional prototypes and all those things, ABS is used. Did you guys get it?
Yes.
So compared to PLA, ABS is far flexible and can stretch easily, and it has high heat resistance compared to PLA. So these are known as motion controllers. They have two systems basically, gantry system and robotic arm system. These receive instruction from the motherboard and a movement that needs to be made. So there will be a thing called extruder, so which needs to be moving in the XY plane in order to print the 3D material. So the movement of those all extruders and other systems are controlled by these motion controllers. So the motherboard gives the input to the motion controllers, then the motion controllers will be rotating their arm based on the given inputs from the motherboard. See, if the motion controllers are not in sync, the movement in the XY plane won't be synchronous, and the prototype which you're trying to build won't be like, it will be having some irregularities in it. So having the proper motion controller is a must do condition. Okay, can anyone guess what are belts? No, just give an input on what belts are. Just take a random guess.
Maybe the surface on which the model will get printed.
Sorry, can you say it again?
It may be the surface on which model get printed.
Yeah, okay. So basically, these belts are connected from motors to the print extruder or some. See, belts in the 3D printers are responsible for the movement of print head. So generally, these are connected from motors. So when you try to move, these belts maintain a certain tension in the belts will be having a certain tension, so that when the motors move, the movement of the motors will be restricted. See, if you try to move some 5 centimeter or something, then these belts ensure that the right amount of tension is in them and the motors move to a certain distance and they won't cross that 5 centimeter bar or something. They transfer the rotatory motion of a motor to a pulley, which results in linear movement. So the correct linear movement so when you have correct belts and correct tension in the belts, then there results in the correct linear movement of the print head. See, generally these belts tend to have a certain amount of tension in them, and they try to maintain the tension throughout the 3D printing process. So there will be restriction in the linear movement of the motors. So hence they tend to maintain a constant tension in these belts. These are also called as tensionoids. Okay, did everyone get it?
Yes.
Yes.
Okay, so I'm gonna give you a task. So try to think of the filaments which are basically used in prototyping other than ABS. So search about the filaments which are used in prototyping other than ABS. Okay. So this is basically power supply unit which provides power for all the materials required. Okay. So can anyone guess what a print bed is?
It's definitely the one on which the model gets printed.
Sorry, can you say it again?
The platform or the
Place
pad
where
on
the
which
3D
model
models
gets
are
printed.
printed.
Yeah, it's correct. Printbed is a platform on which 3D printers are printed. So generally print beds are of two types, heated and non-heated. Can you say why non-heated ones are used for PLA? Can anyone
Because
guess why non-heated ones are used for PLA?
PLA is more heat sensitive.
What?
Maybe PLA is more heat sensitive.
Yeah, it's correct. Since PLA is more heat sensitive, we can't use heated ones. So non-heated ones are used for PLS. So generally these print beds are made of aluminum or glass. But aluminum heats up very fast, but glass gives a nice finishing which is thin and flat. See, while printing a 3D object, if you don't have correct print bed and you won't get a better finishing and the 3D printing object won't be as stable as you think. So having a right print bed is a must necessary condition for it. Okay.
Yes.
See, depending on the printer's model, the print bed can be moving or stationary. It is also referred to as build surface. The another name of print bed is a build surface. The print quality heavily depends on the first layer and the build plate adhesion. So why do you think it's depend on build plate adhesion? So why do you think adhesion is required for build plate? Someone try to guess why we require adhesion.
For stability.
Yeah, it's correct. See, when you're trying to build a prototype, when the first layer comes on the print bed, if it's not stable, so as you go on in try to build the other layers, so the basically the bottommost part is not stable. So as you go on to print it, the layer by layer it goes on distortion. So you won't get the precision in the 3D printing model. So it's better to have adhesion so that it sticks to the print bed and we have a stable base. Okay. So printing on print bed and the first layer is the most important thing in printing of a 3D printing model. So basically the print bed is heated which helps in the first layer adhesion. So when you heat the print bed, it attains a certain temperature. So since the filament is also at high temperature while coming on a print bed, so there will be a certain extent of adhesion in them and it doesn't lead to warping. You will get to know about warping in the next session. So warping is like effects of like problems caused while 3D printing. Okay, can anyone say what are different type of print beds? How can you categorize print beds?
Heated and non-heated.
Yeah, PLA is generally used for which print bed is used for PLA?
Non-heated.
Non-heated. Why?
It's
Because they are heat sensitive.
Yeah, correct. Okay, now we are gonna talk about extruder. So can anyone guess what an extruder is? It's like the heart of a 3D printer.
component which extrudes the
Yeah,
melted
correct.
filament or the material used
Yeah.
for 3D.
See this. Yeah, it's correct. See, this extruder is the main heart of the 3D printer. All the stepper motors, all the inputs from the motherboard, all everything which happens in a 3D printer finally depends on the output from the extruder. So basically the input from the motherboard is given to the stepper motors and then the stepper motors tend to move the extruder in such a way that you can build the given prototype. Okay. So it is one of the major components of FDM 3D printer. So the extruder is also known as cold end is responsible for the delivery of the filament to the hot end. So generally there will be a cold end and a hot end in an extruder. So initially the filament will be sent from the cold end to the hot end. So initially the filament will be stored in the cold end. So when you are building a model, there will be a block between the cold end and the hot end, and the amount of filament required will be passed through the block and it blocks the cold end. So the filament is then going to the hot end, and the hot end will be at a certain temperature such that it is the melting point of the given filament. So then the filament liquefies, then we can use it from, then it comes out of the nozzle and it can be used to print on the print bed. Okay. See, the extruder is also known as the cold end, and it is responsible for the delivery of the filament to the hot end. So the filament goes from cold end to the hot end and ensures that the filament is constantly and consistently replayed. See, if there is any problem in the extruder, even though you have the correct input and the correct, and you are giving instructions everything correctly, if there is problem in the extruder, then there's no point of 3D printing. So it's finally it is the main thing which will be delivering the filament onto the print bed. So we need to check how are the cold ends, whether the hot end is set at correct temperature or not. These are the things which need to be taken care of. Okay. The extruder mechanism gives the capability to retract the filament, especially when the hot end must cover large distances during printing. Extruder settings like speed of the printing pro. See, if you have a good extruder, then the print quality will be high, the precision of the model will be high, the speed of the 3D printing will be high. The major problems in a 3D printer occur in the extruder as well. See, if the hot end is not set at correct temperature, or when you use the wrong filament, or see, then the filament don't liquefy to a certain extent and there will be blocking in the hot end, which doesn't lead to a good model. So basically we need to ensure everything in the extruder is set at right correct parameters. Okay. There are three essential parts in an extruder: stepper motor, driver gear, and idler. The stepper motor provides the power for unwinding the filament spool. So the stepper motor provides the power for unwinding the filament spool and pushing the filament through the hot end. So this basically the stepper motor, what the stepper motor does is it unwinds the filament from the filament spool and then it starts pushing the filament from the cold end to the hot end. The driver gear grabs the filament with its hubs or teeth, and the idler is just a surface to which the driver gear pushes the filament to grab onto it. Okay. So generally there are different types of extruders in the market, but one of the most common ones are Bowden extruder and direct drive extruder. Okay. So as I said, the extruder consists of the cold end and hot end. But generally the cold end and hot end are almost nearby themselves. Generally there's like a, how to say it, it's like a block. There's something which blocks the cold end and the hot end. But in Bowden that's in a normal general extruder. But in the Bowden extruder, the extruder is not directly connected to the hot end. But the hot end and cold end are placed some distance away and connected to a hot end by a Bowden tube. So if this is a cold end and hot end, they are separated by some distance, and those cold end and hot are connected by a tube. So this arrangement reduces the weight on the nozzle for faster and more accurate printing. However, filament control is much harder. See, the filament needs to go through the tube and it needs to reach the hot end. So consider the part which is near the hot end and the tube. So the temperature at that point will be variable. So it might be higher than the, like consider the melting point of the filament is around 280. As you go to that border, the temperature will be varying around 280, 278, 275 and so on. So when the filament is there, when the filament tries to move through the tube, the filament won't be liquefied because it didn't reach its melting point. So the filament will be getting stuck and there will be a problem in extruding the filament. So generally these Bowden extruders are not used because of its complexity. But if it's working in a proper condition, then the printing process will become much faster compared to normal one. See, it's mentioned here. However, the filament control is much harder and the motor load is greater due to extra distance. See, since the stepper motor need to push the filament with more force because those need to travel through the extra distance connected between cold end and hot end through the Bowden tube. Okay. Did you guys get it?
Yes.
Yeah. So did you guys understand why Bowden extruder is not used? Right?
Yes.
Okay. So this is a direct drive extruder. This extruder is directly mounted above the hot end. So this is directly connected to the hot end. The filament goes directly from the extruder to hot end. So there won't be a Bowden tube between the cold end and the hot end. So the filament will be going directly from cold end to hot end. Although see, in the Bowden extruder, there will be an extra mass. I mean, it won't have an extra mass because it will be connected by a tube. But here the whole pressure of that cold end will be falling on the hot end. Although the extra mass of the extruder on the hot end can cause trouble. See, if this cold end is the whole mass of the cold end will be acting directly on the hot end. So while moving the extruder, this might be a problem because in the normal Bowden extruder, you don't need to put more effort because the mass will be very less and there will be a less torque in Bowden extruder. But here there is a more mass and you need to move the more mass. As you have more mass, there will be more torque in this, so it will be very hard to move compared to Bowden extruder. So if we configure it correctly and mount it correctly to that stand, mount it correctly to those motors, then this will be quite easy to use. And it even has more advantages. There won't be any blockage in the tube and the filament will be going directly from the cold end to hot end. So basically, mostly direct drive extruder is used compared to Bowden extruder because of its advantages. So this has more advantages, but the Bowden one has more disadvantages. Because the low travel distance reduces the friction and provides greater filament control. The control over the filament movement is greater here compared to the Bowden extruder. So direct drive extruder is used more compared to the Bowden extruder. Okay. So do you have any doubts? Do any of you guys have doubts?
No.
Okay, so I'm asking you, I've given you a task, right? What is the task? Do any of you guys remember the task which I have given?
Different types of filaments instead of ABS.
Yeah, correct. So try to do it by the next session. Okay, now my friend Grishma will be continuing from here.
Okay, hello everyone. Can anyone just recap me of what all parts you have learned till now? Like, don't give me the explanation, but at least the names of components. Not all, at least 5 to 6.
Extruder, belt, motor, frame,
Uh,
some of the
okay, fine.
components which is
Okay, thank you. And okay, in the extruder part, I know you have heard about hot end so many times. So, can anyone guess what is the work of hot end? Just guess.
To
Heats
melt
the filament.
Yeah, exactly. Heat the filament and okay, 1 minute. Okay, hot end. Hot end is one of the smallest part, but has a high impact on the print quality and material compatibility. It is responsible for melting and depositing the filament on the printer bed. Okay, when the cold end feeds the filament to the hot end melts it to the required temperature and deposits the filament through the nozzle. So hot end, even though it is very small, it has several parts, namely heater cartridge, thermistor, nozzle, heater block, and heat break. Heater cartridge is usually made of a ceramic material which heats up the filament, while the thermistor is a sensor to check the temperature to which the filament is heated. So heater cartridge heats the filament and thermistor is a sensor to check the temperature. Thermistor definitely plays an important role in maintaining proper printing temperature, which influences print quality and layer adhesion. If the filament is heated way above its melting temperature, then the filament will not be deposited properly. So maintaining proper temperature is very important. And nozzle is another part. Nozzle is the tip of the extruder setup and has a small opening from where the filament comes out. A smaller nozzle can produce a more detailed model, while a larger nozzle can print at a faster rate. Like, yeah, of course, a smaller nozzle deposits less amount of filament, so you can get a more detailed model. But larger, if more filament is deposited, then the print can be done faster. Then heater block. Heater block connects the nozzle to the heat break and holds the heater cartridge and thermistor. Heater block is basically a block kind of thing which holds the heat cartridge and thermistor inside it, while the heat break connects the heater block to the heat sink. Heat sink is nothing but the cold end. Cold end is the extruder part which takes the filament and feeds it to the hot end, serving as the bridge between the cold end and the hot end. I hope this is clear. 1 minute. Okay. Is it clear? Hot end part.
Yes.
Yes, yes.
Yes.
Okay. How many parts does hot end have? Don't count it from here. Okay, 5 parts. 5. Okay, next one is POM wheels. POM wheels are guided rubber wheels with rubber rollers with bearings inside. As you can see in the image here, all these rubber wheels are called POM wheels. They are used in mounting the print head and print bed carriages on the 3D printer frame. These wheels are mostly used to provide smooth and low friction movement for the print head and print bed as they move throughout the print space. As you know, during printing, both the print bed and the print head, which is extruder plus hot end, move during printing. So these help in that movement. Basically, they are wheels that help in the movement. Next comes PTFE tube. PTFE tube serves as a filament guide tube in direct drive extruders. As you know, in direct drive extruders, hot end is attached with the extruder. So PTFE tube, it acts as a filament guide. Filament passes from the PTFE tube. PTFE is polytetrafluoroethylene. It is a material which is transparent, odorless, non-toxic, chemically inert, with a low coefficient of friction. In what is the other type of extruder other than direct drive?
Borden.
Yeah, Bowden. In Bowden, as you know, extruder and hot end are not connected directly. So you need a connector. This PTFE tube acts as a connector between the extruder and hotted in a Borden extruder. PTFE may not work effectively in high temperature because it melts and releases harmful gases. It is generally used for low temperature, for materials which have low melting points. Next, control box. Control box is one of the major parts. It is like what? Communication for the operator. It helps the operator to communicate with the 3D printer directly without the use of PC or any other device. This is basically attached to the 3D printer. Using the control box, the operator can start, pause, or stop printing. They can also load print files from external media like a USB or an SD card. The control box interface can be a touchscreen or a plain LCD with physical buttons or a control knob. As you can see, you have some features that can be controlled from the control box. You can start the printing, pause the printing if there is any problem. Yeah, there are some features which can be controlled. Okay, next. Okay, I'm telling you that there is a component called fans. Why do you think there are fans in a 3D printer?
To cool down the extruded filament faster.
Yeah, exactly. To cool down the deposited filament. After the filament is deposited on the print bed, it needs to be cooled down. So yeah, fans cool down the heat generated by the 3D printer. So there are several number of fans in a 3D printer. Sorry. Part cooling fans cool down the printed material, as he told. The hot end fan helps the heat sink in releasing the heat. So yeah, heat sink also, because it melts the filament, it releases heat. So hot end fan is responsible to cool that part. And motherboard fan cools the electric components inside the motherboard, and power supply unit fan avoids overheating of battery. So there are 4 types of fans. Next comes motors, which is pretty much important. They provide the power needed to drive all the moving parts of the printer, like moving the print bed, extrusion, and retracting the filament. Basically, they provide power needed for all the movements. 3D printers commonly use the brushless DC motor called a stepper motor. Stepper motors move in small rotational intervals called steps. These steps are formed by dividing the shaft of the motor into several equal angles. So each input pulse from the controller turns the shaft one step until it reaches the desired position. Okay, nothing to know. Motors provide the power needed for all the movements, and usually stepper motors are used in 3D printers. Okay, fine. I think you are done. We are done with the components of 3D printers. Any doubts in the components? Okay. If you guys don't have any doubts, let's move to another small part, setting up the 3D printer just before the print. So after since you know all the parts of the 3D printer now, you have a 3D model, you have sliced it, and you have the G code of the model. Now what to do after with that G code? First, you insert that G code into the 3D printer using an SD card or USB. Then you should level the build platform. In the control box, you'll have different options. So you have level also. Some 3D printers, like the recent ones, have auto leveling. They level by themselves, but some you should level. Okay, one of the process which most of them uses, you just take a piece of paper, put it in between the extruder and the print bed. I mean, the distance between the extruder and the print bed should be as thin as paper. So you use a paper, and then after you set the distance, you remove that paper. This is one of the process which most of them follow. I think most of the recent 3D printers have auto leveling. They level by themselves. Then you should load the filament. Loading the filament is also one of the important tasks. You should load the filament before starting the print and unload it after the print is over. So there is an option called filament here on the control box. After choosing that, you should basically, there is a hole from which you can put the filament in the extruder system. Then you should put it inside, and you should allow it to melt like little bit to know if it is melting or not, or if there is any problem with hot end or extruder. Just allow it to melt like this. In the second picture you can see, and then you can stop it. Then preheat and print. Before the print starts, you should preheat both the extruder system and the print bed. So the temperatures to which they have to be preheated, you will set in the slicing software only. So preheating is a good way to ensure that the extruder is warmed up and ready to go. So on the control box, you can see how much percentage of the print is over and the remaining time and stuff. Yeah. Some other things you should do is add glue on the place where you wish to print on the build platform. Okay, can anyone tell why you should add glue?
The stability of the model to make it adhesive to the print bed.
For better adhesion so that stability is maintained.
Yeah, better adhesion so that the first layer is intact with the print bed. And you should start the print and watch it do the first two layers to ensure adhesion. So as I've mentioned earlier, if the first layer is printed well, 90% of your work is done. Like mostly everything will go well. So you should watch how it is printing the first one or two layers so that if there's any problem, you can stop the print. Okay, does anyone have any doubts? This is the end of session. We'll have another quiz now. If you have any doubts, you can ask. Okay, fine. If you don't have any doubts, can you just scan this QR code and join the quiz? I'll start it in 5 minutes. Scan the QR code and wait for 5 minutes. I'll start till everyone join. Okay, I hope everyone has scanned. Okay, let me stop the sharing. One minute, I'll start. Okay, first question. Okay, 67% people put it as Slicer software. And it is Slicer software, so the component that reads the 3D model instructions and converts them into printer movements are basically the G code. So Slicer software does that job. Next one. Okay. 86% were correct. They are called support structures. If you have attended session 4, we have mentioned there that there are some overhanging parts. So you should put some support structures to print those overhanging parts. Next one. Extruder heats and deposits the printing material. Okay, here you might have you might have get a doubt what is extruder and what is hot end. I've told that hot end is also responsible to heat and deposit the printing material. Okay, many a times hot end is considered as a component with the extruder. So yeah, many a times it is considered with the extruder, so it is responsible for heating and depositing the printing material. This is pretty much a simple question. It's called print bed. Guys, who put nozzle? I want to see 100% correct answers, please. Oh, finally, 100%. Thank you. Yeah, Seppa motors provide the power needed to drive all the moving parts. Okay, fine. The question is which component ensures the filament is fed consistently into the hot end? So nozzle is not responsible for feeding the filament to the hot end. Nozzle is a part of hot end which deposits the filament on the print head. Extruder gear is a part of extruder which takes the filament from the filament spool and feeds it to the hot end. So yeah, don't get confused there. Nozzle takes it is a part of hot end which deposits the filament. No, it doesn't feed it to the hot end. Okay, next one. Oh, yeah, this is pretty much clear. I told you just before, right? Nozzle is responsible for depositing the material. Okay, this one, just take a guess. I didn't think we introduced that term, but you can guess. It's pretty easy. Yeah, build volume is the maximum physical dimensions that a 3D printer can produce in a single print job. Like the maximum dimensions of a 3D print you can get from that particular printer. Next one. If you have doubt on what warping is a type of defect that you see during a 3D print, during 3D printing. It's a problem. Guys, cool down cooling fan. Such easy question it is. So fans are used to cool down. Ah yes, hot end is used to heat the filament. And we are done with the quiz. Thank you for joining the quiz. Okay, coming to the Karinya, will you send the attendance? Oh yeah. Guys, please do fill that form to get attendance. And if anyone has any doubts regarding this session or the previous session, you can ask.
Can we leave?
One minute, I'll explain you about the assignment. Okay, fine. If you're done with filling that form, assignment for session 6 is to analyze the working of a 3D printing process other than FDM and write a brief report describing its parts. You can choose any 3D printing process. Now we have explained about FDM and its components, right? Just write on how it works and don't write about every part, but at least some 5 to 6 important parts. Just write a report on them. This is the assignment, and submission. You should submit the PDF form of the report on the Google form, which will be sent on the WhatsApp channel of 3D Printing Club. I hope everyone is in that. Everyone's joined that WhatsApp channel. We'll be sending the Google form by evening. Just write the report and submit it in PDF form, and we'll be checking it. I hope assignment part is clear.
Yes.
Okay, fine. If you still don't have any doubts, you can leave.